Just 3 decades ago, the idea of a planet existing outside our solar system was still considered a theory without any confirmed scientific proof. At that time, astronomers and scientists could only speculate about the existence of distant worlds, unable to detect them with the instruments they had. But everything has changed dramatically since then. Today, thanks to extraordinary technological advancements and relentless scientific research, we've confirmed the discovery of more than 5,300 exoplanets. These alien worlds, orbiting stars far beyond our sun, are no longer the stuff of science fiction. They are real, and many of them are just waiting to be explored. In the early days of exoplanet discovery, most of what we found were massive gas giants, huge planets that bore little resemblance to Earth. This was because our technology was better at detecting large, heavy planets that produced noticeable wobbles in their stars. But with each passing year, our tools have become more sensitive, and our detection methods more refined. As a result, we've started uncovering smaller planets, ones much more like Earth in size and composition. Today, scientists have identified over 50 exoplanets that have masses similar to our own planet, and more than 800 that are less than 1.5 times Earth's radius. While many of these planets are interesting in their own right, not all of them fall within what's called the habitable zone. This is the special region around a star where conditions could be just right to support life, where a planet could potentially have liquid water on its surface. For a long time, we didn't know of many Earth-sized planets orbiting within this zone. But that situation is slowly but surely changing. The more we explore, the more we're finding entire planetary systems with not just one, but several potentially habitable worlds. And remarkably, some of these systems are not very far from us, at least on a cosmic scale. Our own galaxy, the Milky Way, is home to countless star systems. Among them are many compact systems centered around stars that share similarities with our own Sunday. But there's a catch. Planets that orbit too closely to their parent stars are usually too hot to support life as we know it. However, things are different when the star in question is smaller and cooler than our Sun. Around such stars, known as red or orange dwarfs, the habitable zone lies much closer in. This brings us to an extraordinary system that stands out as one of the best candidates in our search for life beyond Earth. Located just 23 light-years away from us in the constellation of Scorpius is a fascinating system called Gliese 667, also known as GJ 667. It's a triple star system, meaning it consists of 3 stars gravitationally bound to one another. What makes this system truly special is that it contains the first known example of a low-mass star with multiple rocky planets that could be potentially habitable. These planets orbit within the so-called Goldilocks zone, a region not too hot and not too cold where conditions might be just right for life. This makes GJ 667 an exciting target for further observation and research. The system bears some resemblance to Alpha Centauri in that it contains 3 stars. The primary star, GJ 667a, is classified as a K-type main sequence star. It's an orange-red dwarf and the largest of the 3 stars in the system. Compared to our Sun, it's quite modest, just 73% the mass, 76% the radius, and only about 12% as luminous. Orbiting this primary star at an average distance of 12.5 astronomical units, AU, is the second star, GJ 667b. This one is also an orange-red dwarf, with a mass of about 69% that of the Sun, and it emits only 5% of our Sun's visual light. But the most intriguing member of the trio is GJ 667c, the third star in the system. It's an M-type red dwarf, small, faint, and cold. It has only about a third of the Sun's mass and radius, and its brightness is a mere 1.4% of what our Sun produces. Its surface temperature is around 3,775 Kelvin, which is considerably cooler than the Sun's surface temperature of 5,772 Kelvin. Despite its small size and dim light, this star hosts a planetary system that has fascinated scientists around the world. GJ 667c has turned out to be home to more planets than initially believed. When astronomers first observed this star, they thought there were only 3 exoplanets orbiting around it. But further analysis of the data, combined with additional observations, revealed a more complex picture. It turns out there could be as many as 6 planets in the system, and what's even more exciting is that 3 or possibly even 4 of them appear to be super-Earths located within the habitable zone. This discovery dramatically increases the chances of finding a world that could support life. But before we go deeper, let's understand what a super-Earth actually is. A super-Earth is a type of planet that is larger than Earth but significantly smaller than gas giants like Neptune or Jupiter. These planets typically have a rocky composition, although they might also contain large amounts of ice or other materials. Depending on their atmospheres, they might be capable of supporting some form of life, especially if they lie within the habitable zone of their star. In the Gliese 667 system, the closest planet to the host star is known as Gliese 667 cb. It's a scorching hot world with surface temperatures around 200 degrees Celsius or 392 degrees Fahrenheit, far too extreme for life as we know it. Gliese 667 cb is also the most massive planet in this system. It has a mass roughly 5.5 times that of Earth, which likely means it has a very thick atmosphere. Its orbit is extremely tight. It completes a full revolution around its star in just 7 Earth days. This kind of close orbit exposes the planet to intense radiation and gravitational forces, making it an unlikely candidate for habitability. But further out, things become more promising. The system includes 3 other planets that orbit further from the star, with masses between 1 and 5 times that of Earth, and these are the ones that have captured scientists' interest. One of the most promising candidates among them is Gliese 667 cc, which is the next closest planet after CB. It orbits near the inner edge of the star's habitable zone. With a mass of about 3.8 times that of Earth and a radius roughly 1.8 times greater, it's considered one of the most Earth-like planets ever discovered. A year on this planet, meaning one full orbit around its star, lasts only 28 Earth days. Despite this short year, the planet's conditions could be surprisingly similar to Earth's, making it an ideal target in the search for extraterrestrial life. Gliese 667 cc boasts an Earth similarity index of 0.85, making it one of the most Earth-like planets outside our solar system. The habitable zone around this red dwarf star is incredibly close in, ranging from just 11 cents to 23 cents. For comparison, Earth orbits the Sun at about $1 Australian. If our planet were moved to such a distance from this cool star, it would turn into an icy wasteland. But because red dwarfs emit much less energy, being closer actually puts a planet in the right range for habitability. Gliese 667 cc orbits at around 12 cents, completing its orbit every 28 days. Due to its tight orbit, Gliese 667 cc is most likely tidally locked, meaning one side of the planet always faces the star while the other remains in darkness. This creates a world of extremes, eternal daylight on one hemisphere and perpetual night on the other. Such a setup could cause huge temperature differences between the two sides. However, if the planet has a thick atmosphere, it could help redistribute heat across the surface, balancing out these temperature extremes. That kind of atmospheric circulation could make the entire planet more hospitable for life, not just the areas between the two extremes. Although Gliese 667 cc receives about 10% less light than Earth gets from the Sun, most of that light is in the infrared spectrum. That means the total energy it absorbs might be comparable to what Earth receives, allowing for temperatures that could retain liquid water on the surface. If the planet has an atmosphere similar to Earth's, it could regulate the temperature effectively, keeping the night side from freezing and the day side from overheating. In such a scenario, the night side might even have pleasant temperatures around 30 degrees Celsius or 86 degrees Fahrenheit, comfortable by human standards. Life on a planet like Gliese 667 cc would be dramatically different from life on Earth. The red dwarf star would cast a dim reddish light across the planet's surface, creating an alien yet potentially beautiful environment. Meanwhile, the other 2 stars in the system, GJ 667a and b, are located much farther away, about $230 Australian. That's beyond Pluto's average distance from the Sun. Although they lie outside the main planetary system, they would still be visible in the sky. During the day they might appear as bright stars, while at night they would glow like full moons. Despite its promise, Gliese 667 cc is not without challenges. Red dwarf stars like GJ 667c are known to produce powerful flares, intense bursts of radiation and energetic particles. These flares can be up to 1,000 times stronger than what we experience from our own Sunday. For any potential life on the surface of Gliese 667 cc, these flares could pose a serious threat. The planet's close proximity to its star makes it especially vulnerable to such high-energy outbursts, which could strip away the atmosphere or cause severe climate disruptions if not protected by a strong magnetic field. Adding to the complexity, GJ 667c's magnetic activity can cause large star spots, similar to sunspots but much more impactful due to the star's lower energy output. These star spots can reduce the star's brightness by as much as 40% for extended periods, sometimes lasting months. This variability, combined with the low ultraviolet output of red dwarfs, presents another challenge for life to emerge or survive. The lack of ultraviolet radiation could hinder the formation of complex organic molecules, which are essential building blocks for life as we know it. So, while Gliese 667cc is fascinating, it's also unpredictable. And there's one more thing that makes life on Gliese 667cc quite alien to us: the planet's massive size. The higher mass of this exoplanet creates a significant difference in gravitational acceleration compared to Earth. Since it's a rocky planet, the surface gravity could be up to 60% stronger than what we feel on Earth. That means a person who weighs about 75 kilograms or 165 pounds here on Earth would feel as if they weighed roughly 120 kilograms or 265 pounds on Gliese 667cc. This increased gravity wouldn't just affect how we walk or move, it would impact muscle and bone structure, possibly even how buildings are designed. Life, if it exists there, would have to evolve under this intense force. A planet with higher mass isn't just heavier, it also has a greater ability to retain a thick atmosphere. That means the surface pressure could be much higher than what we're used to. If Gliese 667cc has an Earth-like atmosphere, the pressure might only be a few times stronger. But if it has an atmosphere similar to Venus, things could get extreme. The pressure could be several hundred times greater, reaching levels similar to what we'd experience several kilometers deep in Earth's oceans. That kind of environment would be very hostile for humans but might be just fine for alien life forms adapted to such extremes. Even though Gliese 667cc lies in the habitable zone, the region where liquid water could exist, it doesn't necessarily mean the planet is Earth-like. The conditions might be drastically different. Life here, if it exists, would have to cope with unpredictable light levels, potentially overwhelming atmospheric pressure, and possibly frequent solar flares from its red dwarf star. Still, we shouldn't be too quick to dismiss its potential. On Earth, life has proven to be incredibly adaptable, thriving in boiling acid pools, frozen glaciers, and deep-sea trenches. So, alien life on Gliese 667cc could be just as resourceful, evolving to survive its intense conditions. There are two more intriguing planets in the same system that could also support life. Gliese 667Su and Gliese 667Cf both have similar characteristics, about 2.7 times the mass of Earth and a radius roughly 1.45 times that of our planet. However, they orbit farther away from their parent star. This means they receive much less solar energy, possibly making them too cold to support life as we know it. But there's a twist. If either of these planets has a dense atmosphere, it could act as a thermal blanket, trapping heat and creating conditions where liquid water could still exist, an essential ingredient for life. What makes Gliese 667c even more fascinating is the sheer number of potentially habitable planets packed into one system. Finding 3 planets in the habitable zone is already rare, but 4? That's almost unheard of. According to one scientific study, 5 planets in this system may receive solar radiation ranging anywhere from 20% to 200% of what Earth gets from the Sun. This wide range opens up the possibility that all 5 could, under the right conditions, support life in some form. It's like discovering an entire neighborhood of Earth-like worlds orbiting one single star. But the story doesn't end there. When determining habitability, scientists also look closely at the distance each planet is from its star. For a planet roughly the size of Earth, the habitable zone around Gliese 667c stretches from 0.095 to 0.126 astronomical units on the inner edge, and from 0.241 to 0.251 Australian dollars on the outer edge. Planets within this range could support liquid water. But if a planet is too close, it gets too hot. Water would boil away and the planet could enter what's called a moist greenhouse state, where water vapor traps more heat and leads to runaway warming. Only the bigger, heavier planets close to the star are more likely to resist this effect. Meanwhile, planets on the outer edge of the habitable zone, like Gliese 667g, face the opposite problem. They may be so far from the star that any water would freeze, turning the planet into a lifeless ice ball. Gases like CO2 can help trap heat, warming the surface, but too much CO2 can actually have the opposite effect. It starts reflecting sunlight instead of absorbing it, cooling the planet down. So there's a fine balance. Too little CO2 and it's an ice world. Too much and it's an ice world again, just for a different reason. This balancing act plays a key role in whether a planet can sustain life. Back in 2013, astronomers made a stunning announcement. They had identified at least 6 planets orbiting Gliese 667c, with a possible 7th planet named GJ 667ch. If confirmed, This would make it one of the most tightly packed planetary systems known. Planet H, however, is controversial. If it does exist, it would be the smallest and closest to the star, with a mass just 1.1 times that of Earth. But it orbits at just 0.0893 Australian dollars from the star, far too close for life. The heat would be unbearable, likely stripping away any atmosphere and boiling any surface water. Of the confirmed planets, F and E appear to be firmly within the habitable zone. Planet D might also be a contender, though its exact orbit isn't confirmed yet. That means we have at least 3 or possibly 4 planets, CC, SU, CF, and CD, that may have the right conditions for life. This makes Gliese 667c a rare and valuable target for further exploration. It's not just about finding a single Earth-like planet anymore. This system may be a goldmine of potentially habitable worlds, all orbiting one modest red dwarf star. What this discovery reveals is something even bigger than the Gliese system itself. Around stars like these, known as M-dwarfs, planetary systems can be both common and tightly packed. And since M-dwarfs make up over 70% of the stars in our galactic neighborhood, it suggests that Earth-like planets may be far more numerous than we ever imagined. Instead of spending years searching around 10 different stars hoping to find one good planet, we can now zero in on just one star and potentially find several candidates all at once. It's a revolutionary shift in the way we search for life beyond Earth. With the development of new ultra-sensitive telescopes, our ability to find and study these distant planets is advancing faster than ever. These discoveries are just the beginning. What once seemed like science fiction is rapidly becoming science fact. We're now standing on the edge of something monumental, an era where discovering multiple Earth-like worlds may become routine rather than rare. The only question is, which system should we explore next? Let us know in the comments. Stay tuned for more fascinating cosmic revelations right here. And if you enjoyed this video, don't forget to tap the super thanks button. It really helps the channel grow. Thanks for watching, and we'll see you next time on the journey to the stars.